Incidentally, astronomical occasions take place on a large scale, billions of miles away from the planet, resonating all through the universe. Presently, a similar event is approaching, resulting in shock even among researchers. A red giant star, situated at the outer spans of our system, is emitting unusual signals across the universe. Signals that have been captured by the James Webb Space Telescope. Cosmologists have discovered a great deal shocking revelations about this epic heavenly body. Recognized physicist Brian Cox has issued a grave warning, and a pressing question emerges. Are we on the brink of witnessing a disastrous cosmic explosion that could forever alter the natural night sky? Before diving into further details, make sure to subscribe to our channel if you haven't already. You know about the fire. Now the question awaits. Will this blast influence Earth, and will it be noticeable from our planet? Stay tuned as we explore the answers to these compelling questions in this video. Across the vastness of space and time, where the cycle of heavenly birth, life, and death unfolds in entrancing wonder, one particular star has recently drawn the attention and concern of both cosmologists and the general public. This star, Betelgeuse, stands out prominently as a red supergiant in the constellation Orion, flaunting colossal size and age. Its striking ruddy color and varying brilliance have long fascinated observers. Recent events, however, have further heightened interest in this heavenly colossus. As we investigate the essence of Betelgeuse, we find ourselves near the edge of a potentially stupendous event in the star's life cycle. But what do these transformations mean? Might we witness the start of an astonishingly extravagant display of unimaginable scale? Betelgeuse, flaunting a size approximately 1,000 times larger than our Sun, remains a gigantic giant among stars. Its sheer size stretches the limits of human imagination. Picture a star so immense that, if it were to replace the Sun, its surface would expand past Mars's orbit, engulfing Mercury, Venus, Earth, and Mars within its heavenly grasp. This phenomenal size not only highlights Betelgeuse's physical enormity but also indicates its place in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight period of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it is quite old within the context of stellar life expectancies. Its current status as a red supergiant reflects the culmination of millions of years of stellar evolution, having transformed from a hot blue star into the great red giant we observe today. The journey of stars like Betelgeuse unfolds as a story of constant transformation, driven by the unrelenting forces of nuclear fusion and gravitational pull. One notable feature of Betelgeuse's current phase is its deep red hue, which is due to its relatively lower surface temperature compared to stars like our Sun. While our Sun shines at around 5,500 Kelvin, Betelgeuse's surface is cooler, at approximately 3,500 Kelvin. This lower temperature causes Betelgeuse to emit light in shades of red. But this shade is not merely aesthetic. It provides insights into the star's physical condition and the ongoing processes within its vast gaseous domain. Adding to the intrigue surrounding Betelgeuse is its unusual color history. Ancient Roman and Chinese records suggest that nearly 1,000 years ago, Betelgeuse appeared yellow. It was only after the 9th century that Arabic researchers described it as red. This historical shift in color is not merely a footnote in astronomical records, but a signpost in the star's transformative journey. The changing brightness of Betelgeuse adds another layer of fascination. As a semi-regular variable star, its luminosity fluctuates frequently. This dance of brightness has enthralled celestial observers and astronomers for centuries. Betelgeuse typically follows a 420-day cycle, alongside a longer 5-year cycle noted as far back as 1836 by Sir John Herschel, and perhaps even earlier in Native American oral traditions. What truly sets Betelgeuse apart isn't just its shifting brightness but its irregularity. Unlike many stars that follow predictable patterns, Betelgeuse sometimes deviates from its usual rhythm, changing from dim to bright unpredictably. This irregularity points to complex and lesser-known processes occurring within its massive structure. Recent discoveries have captivated astronomers and stargazers globally. Betelgeuse experienced a surprising and dramatic event now known as the Great Dimming. Everything began toward the end of 2019, when Betelgeuse, the red supergiant shining brightly in the night sky as a notable part of the Orion constellation, began to mysteriously dim. The dimming was so striking that it lost luminosity at a rate of 0.01 magnitudes per day on average, reaching its lowest brightness by February 2020. Betelgeuse, commonly visible to the naked eye even amidst light pollution, largely diminished, an event even amateur observers couldn't miss. However, there's a critical challenge in interpreting Betelgeuse's activities. The time conundrum. When we observe a star like Betelgeuse, we are not seeing its current condition, but rather its past, due to the time it takes light to travel to us. Betelgeuse is located about 725 light-years away, which means the light we see today left the star nearly 7 centuries ago. This time delay makes it harder to predict and track sudden changes in a star's behavior, as we are essentially witnessing events that happened in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent difficulties and limitations of cosmic observations when grappling with the immense scales of the universe and their involvement in the mysteries of time. Understanding remains incomplete. The captivating journey of Betelgeuse's astronomical performance was meticulously tracked by Andrea Dupree, the director of the Center for Astrophysics. Her team, working for the Smithsonian and Harvard, utilized the Hubble Space Telescope for a 3-year study, monitoring changes in Betelgeuse's outer environment. These observations provided an unprecedented understanding of how a variable star like Betelgeuse behaves, with its regular expansions and contractions resulting in changes in brightness. Hubble's sensitivity to ultraviolet light enabled researchers to probe the layers above Betelgeuse's surface, which were partially heated by the star's turbulent convection cells. Furthermore, a detailed analysis of the Hubble spectra obtained at various intervals throughout 2019 and 2020 facilitated the measurement of material movement within the outer environment of Betelgeuse. Specifically, the study focused on the magnesium-2 lines in the spectra, which offer insights into the star's atmospheric conditions. These observations revealed material traveling at approximately 200,000 miles per hour from Betelgeuse's surface into its outer environment. This heated and dense material eventually expanded millions of miles from the star, forming the precursor to the dust cloud responsible for its dimming. Dupree and her team estimated that, during the 3-month event, about twice as much material as usual was shed from the southern hemisphere of Betelgeuse. This substantial mass loss is particularly notable. To answer these questions, scientists, before reaching the point, and despite accurately predicting collapse, massive loss occurred. When exactly this will occur remains uncertain, despite the fact that some estimates suggest Betelgeuse might burst within the next 100,000 years. According to others, it could take even longer. Despite the uncertainty, one thing is clear. When Betelgeuse does finally go supernova, it will be an astronomical display unlike any other witnessed in modern times. The explosion would be so brilliant that it might be visible from Earth at any time of day for weeks, outshining the full moon by hours before gradually fading. Would this occur? Explosions in the cosmos can pose a threat to Earth. Fortunately, due to its distance, Betelgeuse's supernova would not pose any direct threat to the planet. Instead, it would provide a unique opportunity for scientists to study the evolution of stars and supernova mechanics in real time. Astronomers maintain a close eye on Betelgeuse, using telescopes like the James Webb Space Telescope and ground-based observatories. Each new discovery adds to our comprehension of how stars evolve and die, offering a glimpse into the future fate of other stars, including those in our own galaxy. For now, Betelgeuse remains an enigma, an aging giant teetering on the brink of one of the most potent transformations in the universe. Whether it explodes tomorrow or thousands of years from now, one thing will remain constant. When Betelgeuse finally reaches its conclusion, it will have a long-lasting impact on the cosmos, reshaping our night sky forever. In the expansive and difficult journey to shed light on this phenomenon, several hypotheses have been proposed. One theory suggests that the star is entering a stage in the supernova process, aligning with the prevalent belief that Betelgeuse is nearing the end of its lifespan. Another widely accepted hypothesis implicates dust, possibly originating from the star itself, as the cause of Betelgeuse's dimming. A third explanation examines changes in the star's apparent surface layer, the photosphere, which may influence its observed brightness. Thorough investigations using a variety of observational techniques have contributed to deciphering this spectroscopic mystery. Assessments showed a decrease in Betelgeuse's effective temperature, indicating the likely presence of a significant dark spot on the star's surface. This theory found support in observations revealing a temperature drop of at least 170 Kelvin during the dimming period, highlighting major surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from the careful observations of the Hubble Space Telescope. Hubble's precise readings revealed that the dimming of Betelgeuse was probably caused by a significant ejection of heated material into space. This material coalesced to form a dust cloud, blocking part of the star's surface and reducing the amount of light reaching Earth. The formation of the dust cloud was attributed to superheated plasma, which emerged from a large convection cell on the star's surface and traveled through its scorching atmosphere to the colder outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that obscured roughly a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, played a crucial role in establishing the timeline leading up to Betelgeuse's dimming. These observations detected signs of thick, heated material moving through the star's atmosphere in the months preceding the event. By December 2019, ground-based telescopes also recorded a diminishing brightness, particularly in Betelgeuse's southern hemisphere. Initially, this material appeared brighter than the star's usual luminosity, eventually culminating in the formation of a shadow as it scattered outward and cooled. The conclusion was straightforward. This outward flow of material and the resulting shadow were responsible for the sudden dimming of the star. The scale of this ejection is truly remarkable. When Betelgeuse pushed itself into the cosmic spotlight, it expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. The expelled material was believed to be enough to outweigh our Moon several times over, a significant occasion not just for Betelgeuse, but also for the field of stellar mechanics. But what are the repercussions of this massive release of material? Conventional wisdom suggests that red giants the size of Betelgeuse regularly shed mass before reaching the most catastrophic point in their life cycles. However, the scope of this release challenges that notion, hinting at a likely more volatile and unpredictable final stage for such stars. Betelgeuse may be preparing for a supernova explosion within the coming centuries. Later research speculated that such an event may occur sooner than previously thought, possibly even within the next few years. Additionally, the concept of the bow shock adds another important layer to the Betelgeuse puzzle. As this enormous star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock similar to the wake formed by a moving boat. This phenomenon results from the interplay between the star's outer layers and interstellar gas and dust, offering a spectacular display of the star's dynamic behavior and its interaction with the cosmic milieu. However, Betelgeuse's recent behavior, surface cooling and diminished density, observed after the ejection event, has left the star in a disturbed state even years later. Hydrodynamic simulations suggest a link between convection activity, subsequent mass ejections, and changes in its oscillation modes. This ongoing instability raises questions about the internal mechanisms driving these modifications and the potential effects on the star's future. Additionally, Betelgeuse's observed mass loss rate exceeds that of many other stars, reflecting a complex interplay of internal forces. With energy continuously dissipating through shock heating and mass ejection, Betelgeuse's rhythm is shifting. The very nature of this mass loss points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to reconsider their models of stellar evolution. The profound changes in Betelgeuse's behavior continue to spark widespread debate among astronomers, who are now rethinking their understanding of the final stages of a star's life. While stars like our Sun will end their lives relatively calmly, transforming into white dwarfs, Betelgeuse's enormous size and unique characteristics suggest it may follow a much more violent path. As a supergiant, It has already surpassed the size and mass required to evolve into a white dwarf. Instead, Betelgeuse's inevitable fate seems to lie in a spectacular supernova explosion, a cataclysmic event that will leave behind a remnant core, possibly a neutron star or black hole. The scale of Betelgeuse's mass destruction may indicate that this transformation could occur earlier than expected. It is believed that red supergiants like Betelgeuse typically shed significant mass in the years leading up to a supernova. However, the most recent event, known as the Great Dimming, suggests that this process of shedding might be more unpredictable and tumultuous than previously thought. This unpredictability has resulted in a greater sense of urgency in studying Betelgeuse, one of the last remaining red supergiants likely to undergo such an explosive transformation within a human lifetime. In the future, astronomers will continue to closely monitor Betelgeuse, particularly regarding its mass loss rate, which still exceeds that of many other stars. These ongoing observations are crucial in understanding how mass loss contributes to a star's final stages, and may even offer new insights into the mechanisms behind supernova explosions. The fact that this process is occurring relatively nearby, only 725 light-years away, gives scientists an unprecedented opportunity to witness a stellar death firsthand. When, and if, Betelgeuse eventually explodes, it could become bright enough to be visible during the day, offering a rare and extraordinary spectacle for both professional and amateur astronomers, as well as the general public. While scientists are still undecided regarding the precise timing, this event could potentially change our understanding of stellar evolution and the fate of massive stars. Technological advances and new tools to study stars like Betelgeuse will only improve, allowing us to unlock even more of the universe's mysteries. With every new discovery, the celestial realm becomes even more fascinating. The unfolding drama surrounding Betelgeuse serves as a reminder of how little we truly know about the final stages of massive stars. While its eventual supernova may still be years, or even centuries, away, its story continues to captivate astronomers and inspire curiosity across the world.